sky. We see them flying free. That's just like you and me. Everyone is lonely sometimes, but I would walk 1,000 miles to see your eyes. You are not alone, we are family. Hold me, let's escape all this reality.
Hello my students, you're welcome to yet another edition of OS Learning Platform, and today we have UCE Physics 535/1, the one I termed the Physics Beyond Nature. Today, kindly gather and we discover the mystery of the universe and one of the phenomena that do happen in the universe is the day and night formation. 2. Formation of winters, summers, spring, what I mean seasonal changes. And all these are brought by majorly 2 factors, that is rotation and revolution. One of them causes day and night, and the other causes seasonal changes. So pause the video and guess which one causes day and night and which one causes seasons to change or make seasons to change. Well, the rotation and the revolution of the earth around the sun. And also we shall look at the day and night formation, shadow formation, what we call the eclipse, and the changes in seasons. Now day and night is as a result of rotation of the Earth on its axis, on its tilted axis, and that axis is approximately 23.5 degrees. On the other hand, revolution of the Earth around the Sun is the one that causes seasons to change: winter, summer, spring, etc. And there are majorly 4 seasons that we shall discover in this tutorial. The light and shadow. Day and night formation. Day and night formation. So the Earth shows 2 types of motions. That is the revolution and rotation. So we start with rotation and revolution. So that is our Earth, as you can see. So the spinning movement, or the moving around of the Sun on its axis, is the one we call rotation. The Earth rotates from west to east and takes 24 hours to complete one rotation around its axis. So taking this as the axis, you can see it is moving from west to east. And this revolution takes 24 hours. 12 day, 12 night. So one day and night are of 24 hours. Rotation causes day and night. We have cleared that one. The Earth rotates on its tilted axis, and that axis is about 23.5, causing day and night. Due to the spherical shape of the Earth, only half of its part gets light from the Sun at a time. The portion facing the Sun experiences day, while the other half away from the Sun experiences night. So that's why we are saying day. This part is day and the other part is night. Now revolution. Revolution. The movement of the Earth around the Sun in a fixed path, what we call an orbit. I think it's on the 3rd orbit of the 3rd orbit. The movement is there. So the Earth takes about 365 and quarter days, that is ultimately 1 year, to rotate around the Sun. Shadow in space, eclipse, senior 2 work, senior 1, senior 2. We have different types of eclipse, and the eclipse are the most spectacular schedules cast by the Earth and the Moon by blocking the sunlight on reaching each other. Eclipse occur due to the revolution of the Earth and the Moon. The position of the Moon and Earth keeps on changing due to revolving movements. Eclipse occur when the Sun, the Earth, and the Moon are in straight line. So when those elements appear in straight line, eclipse occurs. The first one is lunar eclipse. When the Earth comes between the Sun and the Moon, lunar eclipse occurs. That's very true. Lunar eclipse occurs. Lunar eclipse, that is when the Sun and the Moon, when the Earth comes between the Sun and the Moon. The Moon is always at a fixed point. So we can see that the darkest part is called umbra, and so the darkest part of it is the umbra, where we full total darkness, umbra. Then partial darkness, this part here is the penumbra. So this is our Earth, this is our Moon, and this is our Sun. So these are rays, sun rays. They must have arrows as you're drawing them. When Moon is completely in dark shadow of the Earth, it is called total eclipse. Like there's total darkness on the Moon due to the light being stopped from casting its self on the Moon. When Moon is partly hidden by the shadow of the Earth, it is called partial. So you can see part of the moon is dark and the other side is not dark. Solar eclipse. When the moon comes between the sun and the earth, solar eclipse occurs. Solar eclipse occurs, and that is why we are seeing our moon. The moon is between the sun and the earth, so it casts shadow. That is the annular eclipse, then the partial eclipse. So this is partial darkness, and then there's total darkness. When sun is completely hidden by the moon, it is total solar eclipse. On the other hand, it is partial. You can see the diagram. There's total darkness on the earth. When only a part of sun is hidden, it's called partial eclipse, and that's what we experience in actually we mostly experience in Uganda. I think it once happened in northern Uganda, and this is partial, part of the country, part of the earth just experiences that darkness. Then here is darkness. I don't know whether it has ever happened, total solar eclipse, where the total earth is on dark, it's experiencing darkness. And they are okay, total solar eclipse. So basically that is what we have as far as day and night is formed. Day and night are formed, shadows are formed, meaning eclipse. And then we move to the next one to describe how seasons change. So we can ideally see that it is as a result of rotation. It is as a result of rotation of the earth on its axis. So we agreed that this is our earth tilted at an angle. So this earth moves in such a way that it moves from west to east, and this rotation takes 24 hours, meaning a half is 12, a half is 12. Now the face that is receiving sunlight is the one that experiences day, and then the other part that receives the shadow of the earth itself is the one that receives night. Now this tilt affects its season as it is taking the revolution around the sun, whereby the tilt makes the northern hemisphere, this is the northern hemisphere and the southern hemisphere. So the tilt is in such a way that at some point the southern hemisphere is away from the sun, and on a certain point the northern hemisphere is actually also away. So when one is away, the other one is towards. So southern hemisphere away from the sun, northern hemisphere is towards the sun, meaning all parts in the northern hemisphere feel that high temperature or winter. Then parts or countries in the southern hemisphere experience what we call summer. Anyway, let's get to that presentation and we see how the revolution affect seasons or bring about season changes. Changes in seasons. This is as a result of revolution of the earth around the sun. I repeat, it is a revolution of the earth around the sun, taking 365.25 days, and that is 1 year. Number two, what brings about the season change is the tilt of the earth the Earth is tilted in such a way that it makes an angle of 23.5 with the horizontal, and that tilt, sorry, with the vertical, and that tilt, that is the axis itself. That tilt makes part of the hemisphere to experience high intensity of radiations and sunlight, and on the other hand, the other part experiences low intensity, though this thing keeps on reversing. And maybe to understand it better, let's watch this. Viewers, let's watch this video. Let's watch this video.
Have you ever wondered why we experience different seasons throughout the year, such as spring, summer, autumn, and winter? Well, the answer lies in the Earth's motion around the Sun and its tilt on its axis. The Earth rotates on an imaginary line called the axis, which runs through the North and South poles. This rotation takes 24 hours to complete, which we call one day. The Earth also orbits around the Sun, and this orbit takes 365 days, which we call 1 year. Earth is tilted on its axis at an angle of 23.5 degrees. This tilt is what causes the changing of seasons. As the Earth orbits the Sun, different parts of the Earth receive different amounts of sunlight depending on the season. As the Earth orbits the Sun, the northern and southern hemispheres experience opposite seasons due to the tilt of the Earth's axis. During the spring, the northern hemisphere begins to tilt towards the Sun, bringing longer days and warmer temperatures. This is the time when flowers and trees start to bloom. At the same time, the southern hemisphere begins to tilt away from the Sun, marking the start of the autumn season. As the Earth moves farther from the Sun in its orbit, the northern hemisphere reaches its maximum tilt towards the Sun, resulting in the summer season. This is the time when the days are the longest and the nights are the shortest. The northern hemisphere receives the maximum amount of light during this time. At the same time, the southern hemisphere reaches its maximum tilt away from the Sun, resulting in the winter season. The southern hemisphere receives the minimum amount of light during this time. As the Earth continues on its orbit, the northern hemisphere begins to tilt away from the Sun, resulting in shorter days and cooler temperatures. This is the time when flowers and trees begin to shed their leaves, marking the start of the autumn season. At the same time, the southern hemisphere begins to tilt towards the Sun, resulting in the spring season. Finally, as the Earth reaches its closest point to the Sun, the northern hemisphere is tilted away from the Sun, resulting in the winter season. This is the time when the days are the shortest and the nights are the longest. The northern hemisphere receives the minimum amount of light during this time. At the same time, the southern hemisphere is tilted towards the Sun, resulting in the summer season. The southern hemisphere receives
Everyone is lonely sometimes, but I would walk 1,000 miles to see